So we're here to talk through this Kakuro puzzle with a pinwheel theme. Like many Kakuro puzzles, it starts with small clues that intersect with only one digit in common. A clue like a 16 in 2 cells is 9 and 7. A 23 in 3 cells is 9, 8, and 6. Only a 9 is in common, which gives us this kind of progress. 24 is 9, 8, and 7. If this is 8 and 6, only 8 is in common in this cell. We can use that to, for instance, fill out this section. Similar intersections hold true down here, where 7 in 3 cells and 4 in 2 cells breaks like this. That now intersects with a 6, which can only have a 2. 1, 2, 3 is the value of these, so the 4 sits across. You get something like this. There's a last version, which isn't about an intersection so much as a max-min. Max-min is where you have a smallest possible digit. This is something like a 6. A 10 across and 3 has the largest possible digit is a 7. But that means an 8 or 9 can't go into the cell, so a 6 goes in here. The remaining digits for this clue are 1 and 3. A 1 has to be what goes across the 6. If it was a 3, it'd be 3 plus 3. We get 9, 8, 9, 8. And there's one last easy spot in this puzzle. It's based on that, and it's another max-min cell. It's right here. And how do you find these? Look for things. A 12 in 4 cells looks pretty small. A 15 in 2 cells looks pretty large. So the intersection of a small clue and a large clue, at least conceptually, is where you're looking for this. The largest digit in a 12 across of this form is 6, which would come with 1 plus 2 plus 3 plus 6. 6 is here, you get 9, and that's exactly the max-min. The smallest digit a 15 clue can have is a 6. We're left with 1, 2, and 3 in the remaining cells. I guess I'll mark those all in. There's almost a max-min here, it just doesn't resolve, so this needs to be at least a 3 or 5. Those are the only values left for it. It'll form a 9 or 7. So the next step, and actually a lot of the next steps will still be in this max-min theme, but they'll now actually use not just one cell like we had here, but multiple cells. The 30 clue looks interesting because it's going to be 6 or above in all places, so I'll just mark that. The 39 and 6 cells is also interesting. It now is used to 4, so it's going to be 5 and above in all places. And I'll just actually mark in these spots, because these spots are 2 that will be critical. 17 is a tricky sum to get to. It has one of 2 forms, 1 plus 2 plus 3 plus 4 plus 7, where 7 is the largest possible number, or 1 plus 2 plus 3 plus 5 plus 6, where 5 and 6 together are the largest numbers. And what we see is with a limit of 5 or larger and 6 or larger, there's a max-min intersection where these 2 clues at their smallest possible values, 5 and 6, leave just enough for the remaining cells. And so this is a tricky step to see, but if you can see it once, what you'll find in this puzzle is you have to find it 4 or 5 times, and that's how we're going to make headway. We now have placed the minimums that we had possible for these. This is now 6 or larger and 7 or larger. Now what you'll find is this column has a similar max-min with these 2 cells. If this is the smallest set, which is 6 and 7, that leaves behind 10 total. 1 plus 2 plus 3 plus 4 is that set of 10 total. So this has to again be as small as possible. We're left with a 2 and a 4. 11 across can't have a 4 in it, so it has to be this set. We had before that 3, 5 would form a 9, 7 option up top. The 7's now used. This has to be a 9. That leaves a 3. We place an 8 here. This clue is going to take 1 and 5 left over. The 1 is forced from the column, or the 5 is eliminated from looking below. Get to this. We have 2, 3, 2, 3. Now we can do a similar kind of logic down below. Let's just write sort of the first step, which is this has to be 7 or more, 8 or more, 9 or more. 7, 8, 9 left over. This is the only clue, and in part, one of the things, while this puzzle doesn't have all of its clues given, the clues are used pretty sparingly, but when you have just one clue, you should focus on this clue and this intersection. If 7 is used here, we're left with 1, 2, and 4 as the remaining digits. We're seeing another 39 here. If you didn't see it before, 39 is all the digits from 4 to 9. So the smallest it can be is a 4. With a 7 and above and 4 and above, these 2 at their smallest values will leave just enough for the remaining places. It has to be a 1 and a 2, a 1 and a 2. Now we're going to look across. Here we don't, 1, 2 can be 8, 7, not a constraint, but this is interesting here, 29 in 5 cells. The largest sum I can get from these two together is 2 and 3, which is 5. That leaves behind 24. 24 is a pattern we've seen before. It's 9 and 8 and 7. So this is another max-min case now looking across where the two larger values have to be used. You get this. I'm just going to take that this is an 8 and finish out this clue. By elimination, the 8 has to be in the cell, leaving the 9 there. We said this was 9, 8, 7 left over, so that's this. This set was everything from 4 to 9. The only digit that's left in the cell is a 6. A 9, 8 here, we have a 9, 8 here. Can force a 2 up here. The next thing to look at now in this column, and I think it's from this, we have a cell that has to be 7 or larger. We have a cell that has to be 8 or larger. We're trying to get to a value of 25. 7 with 8 is a total of 15. 15 leaving behind 4 cells that sum to 10. That's the smallest possible sum that you can have in 4 cells, but that's going to be required. So again, we take the minimum of these maximum values, leave behind 1, 2, 3, 4. The fact we can no longer use 5 is what resolves the bottom down here. Like this, we have 1, 2, 1, 2. 26 looking across, it has to take the larger value of 2 or it's not going to get to be filled, so 2 with 9, 8, 7 will work. Like this. We now have one other kind of step besides the max-min step to finish the grid, and that's looking at this clue very carefully. 36 in 6 cells is missing 9, a sum of 9 in 3 cells. And the digits that we have left over here, if you look at them, are 1, 2, 3, 4, 7, and 9. If we're missing 9 in 3 cells, we have to keep a 9, we have to keep a 7. The only way to be losing 9 is to be losing these. So the actual set of digits that's missing here has to be 2, 3, 4, and the digits we have to place are 1, 7, and 9. There's only one spot left for a 7. That leaves just one spot for a 9. That leaves one spot for a 1. Having a 1 in this group left 34 behind in 5 cells. 34 in 5 cells is a fixed group, which is 9, 8, 7, 6 with a 4. 4 is the smallest of that range, and it's also the largest this can take. So we get something like a 4 here and an 8, 6, 8, 6. This clue is always 1, 3, 1, 3. 29 coming across, we're using a 2. We need to take a fairly big number here. This has to be 3 or smaller. But if we take a 3, it leaves behind 24. If we took a 1, which is the other option, we leave behind 26, and that's just not possible. So we take the max on this minimum size clue. That gives us these. We're left needing a 9, 8, 9, 8 in this set. These two pairs now account for both of the 9 and 8, so that leaves us 7 here. Total sum of 24 in those cells, so the remaining cells add up to 3. That's 1 with 2. This is the 2. This is the 1. I guess I could have marked this much earlier, but this 8 makes this a 9, makes this an 8, makes this a 9. We now think about this total clue. 12 so far used. If an 8 is there, another 2 is here. That's no good, so 6 is here for a 4. Now getting to the very end of the puzzle, the 6 down, 1 and 2 already in the row, so 3 is the only one left. 1, 2, 3, 4 now in the row, so the only digit left for the cell is a 5 with a 1. The 1 is going to cancel here and force 1, 2. That gives us a 6. We don't have any clues that are eliminating here, so the most useful place to probably look is right here. 1, 2, 3, 4, 5, 6, 8 are all there, so this could be a 7 or a 9. A 7 is going to make 21 in these cells. 24 will leave behind 3 with 2 to go. That can be 1 and 2. If it's a 9, it's going to be too small. So we had to take a minimum there. 1 and 2 left over with a 1 already here. Do this. And we get through this puzzle. I think some of the test solvers said it was an easier than they expected Saturday, but they were very good at seeing the min-max rules, which we see all throughout the grid. Even tricks like here, seeing that when we have just 3 of the digits placed, the 6, the 8, and 5, we have a unique set of what's missing left over. These are some of the tricks you just have to get better at seeing, and particularly sums you have to get better at recognizing as important partial sums. Example here, for instance, with getting to 24 left over, other cases of the same. So hope you learned a little bit about this puzzle. We went through it sort of fast, but it does repeat one kind of logical step a whole lot. So it's a good training exercise in looking for max min sets, particularly pairs of cells that work together to constrain the grid. So hope you enjoyed the puzzle, and we'll see you again soon.